Hey guys, welcome to problem set 3.4. We're going to do some more proofs here, but all we're looking at, and I've already filled this table out for you, is converses of our parallel lines theorems. So you know if two lines are cut by a transversal and the lines are parallel. So let's say those are parallel. And we have two lines cut by a transversal. So here comes our transversal. Then we have these theorems that alternate exterior angles are congruent. So like this angle and this angle are congruent. We know that consecutive interior angles are supplementary. We know alternate interior angles like this one and this one are congruent. And we know corresponding angles, like ones in the same position, are congruent. So now what we're going to do is the converse of all those things, which is we need to switch the if and then. So here we have two lines are cut by a transversal, and we're going to prove that the lines themselves are parallel. So the lines will be parallel if corresponding angles are congruent. So if we have two lines cut by a transversal and we can show that corresponding angles are congruent, then we know that the lines are parallel. Same thing here. We have two lines cut by a transversal. If alternate interior angles are congruent, then we know that the two lines are parallel. So we're just going to show that angles are congruent, either corresponding angles are congruent, alternate interior angles are congruent. Here we have alternate exterior angles are congruent. So if we can show that alternate exterior angles are congruent, then we know that the two lines are parallel. And then the last one is consecutive interior angles, or same side interior angles, are supplementary. So if we can show that same side interior angles add up to 180 degrees, then we also know that the lines are parallel. Okay, so let's go through some proofs. If you want to go ahead and try any of these on your own, which you should, but if you want to watch this first example first and then try one on your own, that would be fantastic, and then you can check the key to the C. All right, so let's go through the math first. So we're going to show whether or not M and N are parallel. So here we can find these two angles because they are a linear pair. So we know that 2x plus x will equal 180 degrees. Let's move this down here where I have some room to work. Okay, so you can solve for x and get 3x equals 180, and therefore x equals 60. So if x equals 60, then we know that this is 120 degrees, and this is 60 degrees. Okay, now down here, we have vertical angles. Vertical angles are congruent, so we can set these equal to each other. 3y plus 15 equals 190 minus 2y. Solve this. I'm going to add 2y and subtract 15. Get 175, and so y equals 35. Plugging in 35 for y will get me 120 degrees here, or 120 degrees here, whichever way you want to look at it. And now we have two ways to show this. We have alternate exterior angles right here, or we have corresponding angles right here are also congruent. Either one of those proves that the lines are parallel. So let's write it in a more formal proof here. Okay, so we have statements and reasons. So we probably should say given the picture or something along those lines. So let's just say given the picture. I'm just going to say picture. Given. I don't know if that's necessary to write, but we should always start with the given information, I think. And then our next statement, we can say we know that 2x plus x equals 180, which is what we did next, remember? And that is because of the linear pair postulate. Okay. After we found that, we solved for x and found x is 60. We're just going to say here algebraic properties rather than go through every step. Okay. Then next, we knew that 3y plus 15 was equal to 190 minus 2y. So I'm just going in order of the work we did over here and just explaining how we knew that. So we know those two because of vertical angle theorem. Okay. And then we can solve this for y, which was 35. And again, we can just say algebraic properties there. Now we have a new reason that we're going to use next, and that is, let's actually give these angles some names over here, just so we can call them something. I'm going to call this angle A, and this angle B. So this is angle A, this is angle B right here. Okay. Then on number 6, we found angle A to be 120 degrees. And that is because all we did was we took our x value and plugged it in for x. So that's called substitution. We substituted an x value in for x. And then our next step, we found the measure of angle B to also be 120 degrees. That was also because of substitution. And then finally, we now know that line M is parallel to, remember that notation means parallel, line N because of the alternate exterior angles converse, which is what was listed on the first page. Alternate exterior angles converse. We have our QED, or our 3 dots, or of course, boom, which you'll never write in another class because that's only something we do. All right, so maybe you want to try the next one on your own. Pause the video, give it a shot. All right, so here we have, let's see, looking here, we have 40 degrees. We can find angle A because that's 90 degrees right there. So we know angle A is going to be 50 degrees. So let's throw that in there. Okay. And then angle F is also 50 degrees. And now, look at what we have. We have consecutive interior angles are supplementary. And that's enough to prove it right there. We could have also gone with saying B is 130 degrees. And then these two are congruent, which are alternate interior angles, which we then would know that the two lines are parallel. So there's different ways to do these proofs. So you might have come up with different information here. You could have even found angle G right now to be 130, and then that's corresponding with that angle. And so if corresponding angles are congruent, then we know the two lines are parallel. So like I said, a bunch of different ways. So let's write this one in a more formal proof. A lot less steps than the previous one. All right, so we have our statements and reasons. All right, so statement 1, let's just say picture. Oops, I do that all the time. Put a 2 over there. All right, so statement 1 is picture, and that it was given. Then the first thing we found was the measure of angle A. So we know A equals 50. And remember, that's because these three angles add up to 180. And so that's the triangle sum theorem. Okay, after we found A, we found F to also be 50. And that is because of the vertical angle theorem. which says that vertical angles are congruent. And then we now know that line R is parallel to line T because of the consecutive interior angles converse. Yikes. Okay. QED, the quadrant demonstrandum. That's that which was to be demonstrated. All right, let's try this next one. If you just kind of look at the problem, like we have this angle, so we can either find this angle, or sorry, not that angle. Basically, this is the only angle that has a relationship with that, and they are alternate exterior angles. So, you can kind of see maybe where you're supposed to go from the very beginning. But these two angles right here, well, there's a couple ways to do this. These two angles right here add up to 180 degrees because they're a linear pair. So we could do that. 3x plus 15 plus 2x plus 5 equals 180. Or these are, oh, we can't set those, never mind. I was going to say we could set these equal to each other, but we can't. We're trying to show that they're equal to each other. We don't know they're equal. These two we know are a linear pair, though. All right, so then we have 5x plus 20 equals 180, just combining like terms. So 5x equals 160, so x equals 32. Once we know x equals 32, again, I'm going to call some angles, give some angles some names. We'll call this A, we'll call this B. So we can find A is equal to 111, plug 32 in right here, calculate it. And then plug 32 in right here and calculate it, and you're going to get 111 again. And so, we've now shown that those two things are equal, which means the two lines are parallel. So again, let's write this into formal proof. We have our statements and our reasons. Let's say given. Let's just say picture. It's given. Okay, and then the first thing we did is we set these two things, added these two angles together. So we say 3x plus 15 plus 2x plus 5 equals 180. And that is the linear pair postulate. And then from there we found the value of x to be 32. And again, we can just say algebraic properties. And then we had to plug 32 in for x. So anytime you do that, that's the reason for that is substitution. So we got a equals 111 degrees. Substitution. Then we found b equals 111 degrees. Substitution. You could probably write these as separate statements also. I mean, as a single statement instead of two separate statements. Just say a equals 111 degrees, b equals 111 degrees, and you could say substitution once. So to show you what I mean, I think this would be acceptable. So we can say statement 4 is that. Oops. And then we could just say, like that, substitution. So we did both of those for the same reason. I think that would be acceptable. Looks nicer if it looks like that, I guess. And then statement 5, since we showed those two things are equal, we now know line K is parallel to line J. K parallel to J. And that is because of the alternate exterior angles converse. Boom. All right, last one. If you haven't tried one on your own yet, maybe try this one, because you need to be able to do these things on your own. Give it a shot. You don't need to try it for an hour, but try for a couple minutes and see what you can come up with. All right. So here I'm going to label some more angles for later. We'll call this A. This one's B, C, D, and you don't know it yet, but I'm going to use this angle right here. We'll call that E. All right, so the only thing we can do here is add up the three angles inside the triangle. So 2x plus 4x plus 3x is equal to 180, which gives us 9x equals 180, which is x equals 20. Once we know x equals 20, we can find angle B by substituting 4 times 20, so 80. Once we know B, we can find E right here, because those are a linear pair, so they have to add up to 180, so E must be 100. And then right there, we showed that D and E are congruent, and those are corresponding angles, and therefore we have shown that corresponding angles are congruent, and now that proves that the two lines are parallel. Okay, so let's just put this in a more formal setting over here. We've got let's go Christmas colors. We've got statements and reasons. Statement 1, picture, given. All right, then what do we do first? We added the three angles. 2x plus 3x plus 4x equals 180. That's the triangle sum theorem. And then we solved that and found x. So we get x equals 20. And we can just say algebraic properties for that. Then we found, again, just going through our steps over here, then we found B to be 80, and that was substitution. And then we found E to be 100, and that was the linear pair postulate, because they formed a line, so they have to add up to 180 degrees. And then finally, that proves that P is parallel to Q. And that is because we show that corresponding angles are congruent. So it's the corresponding angles converse. And that's it.